You know, for years, the story of AI has been all about building one giant, all-knowing brain, right? A single, monolithic intelligence. But that story is starting to crack. Today, we're going to explore why that whole vision is hitting a wall and what's emerging from the rubble. It's a smarter, faster, and radically different future for artificial intelligence. So let's take a closer look at where those cracks are starting to show. Just look at this image. It really captures this moment perfectly. On one side, you have the old idea, this massive, dense, kind of opaque block of AI. The goal was simple, really. Just make it bigger, feed it more data, and, hope intelligence just emerges. But as we're all starting to see, this approach is fundamentally brittle. It is literally cracking under its own immense weight. And in doing so, it's revealing a much more elegant, structured, and ultimately more powerful architecture that's been hiding underneath all along. So what's actually causing these cracks? Well, the whole bigger is better philosophy is colliding with some very hard, very real-world limits. Let's break down exactly what those are. Okay, now this is fascinating. It reveals a hidden truth about AI costs that most people don't think about. We hear all the time about the massive expense of training a model, right? But here's the thing. That's a one-time cost. The real monster, the dominating burden, is inference. The energy and the expense of actually using the AI over and over and over again. And as this graph shows, that cost is on an exponential, completely unsustainable path. And it's not just about money and energy either. The pursuit of scale is crashing into three fundamental walls: the physical limits of compute, the cognitive limits of reasoning, and the quality limits of data. You can't just throw more servers at these problems. Let's actually look at each of these walls one by one. Okay, let's break these down. First up, you've got compute and energy. We're talking about data centers consuming so much water and power that they're causing local grid failures. That's a hard physical limit. Second, there's reasoning depth. Sure, large language models are amazing mimics, but they really struggle with complex, multi-step logic. They're masters of pattern matching, not deep, verifiable reasoning. And finally, data quality. We've basically fed them the entire internet, and now we're just seeing diminishing returns from all that noisy data. So, if the monolith is failing, what comes next? This is where the whole story pivots. We're moving away from that single, know-it-all generalist and toward a society of specialists. It's a completely new way of thinking about how to build intelligence. And this really sets up the two competing philosophies. On one hand, you have the old guard, top-down artificial general intelligence, or AGI. On the other, the challenger, a bottom-up approach called domain-specific superintelligence, or DSS. These are two fundamentally different paths for the future of AI. And this table just brilliantly illustrates the differences. AGI is a monolithic generalist, fed on internet noise, and it runs on energy-hungry GPUs. Its strength? Broad factual recall. DSS, on the other hand, is an ecosystem of modular specialists. It's trained on curated, high-quality data, and it runs on hyper-efficient new hardware. Its strength? Deep, verifiable, compositional reasoning. When you lay it out like this, the advantages of the DSS approach become crystal clear, right across the board. So, how does this new approach actually work? Well, it all starts by fixing the data problem. Instead of just dumping raw web text into a model, the DSS approach first distills all that chaos into structured models, things like knowledge graphs and formal logic. This provides the crucial grounding that these pure statistical models lack. It's all about quality over quantity. The next layer is in the software itself. This is what's called the neuro-symbolic bridge. Basically, it connects System 1 thinking, that's the intuitive pattern recognition of neural networks, with System 2 thinking, which is the rigorous, formal logic of symbolic AI. And the result? You get an AI that isn't just fluent and conversational, but one whose outputs are mathematically guaranteed to be verifiably true. And finally, the architecture itself is completely different. Instead of one giant model, think of it more like Lego. You have these specialized blocks: a biochemistry block, a supply chain block, a legal framework block. You can swap them in and out without having to do a multi-million-dollar retraining of the entire system. This solves a massive problem in AI called catastrophic forgetting. It's a real game changer. But here's the thing. This brilliant new software, it can't run on yesterday's hardware. To truly unlock this modular real-time paradigm, you need a completely new kind of engine. And this brings us to the hardware revolution. This diagram shows the fundamental difference.
On the left, you see a traditional GPU. The problem is that the memory is far away from the compute core, which creates a huge latency bottleneck. It has to constantly go fetch data, which takes time and wastes a ton of energy. Now look at the right, the new LPU, or language processing unit architecture. See how the memory, the SRAM, is embedded right next to the compute cores? This gives it instantaneous access. No bottleneck, no wasted cycles.
Okay, let's look at the numbers because this is where it gets really wild. An Nvidia H100 GPU gets you about 60 tokens per second. The Groq LPU, around 500 tokens per second. And let's be clear, this isn't a small improvement. This is a seismic leap. It enables things that were just impossible before, like truly real-time conversational voice, instant code generation, and complex agentic AI systems. Put simply, we are looking at an over 8-fold performance leap. And it's a leap in the single most important metric for the future of AI, inference speed. This isn't just about making things faster, it's about making entirely new things possible. It's a true game changer. Now, this isn't just some cool idea from a research paper. The market has already spoken, and it placed a massive $20 billion bet that this modular, LPU-powered future is the right one. Just check out this timeline. It's kind of crazy. In September of 2025, Groq, the company behind the LPU, was valued at nearly $7 billion. Just 3 months later, on Christmas Eve no less, Nvidia swooped in and acquired its assets for $20 billion. That's a nearly 3 times premium in just 3 months. The whole industry took notice. And here's the clever corporate maneuvering behind it all. See, regulators can block massive semiconductor mergers, so Nvidia couldn't just buy Groq outright. Instead, they structured the deal as a non-exclusive IP license and a talent acqui-hire. This allowed them to absorb the crucial LPU technology while brilliantly sidestepping any antitrust reviews. Pretty slick. So why pay so much? Well, it was strategic insurance. Nvidia already dominates AI training with its GPUs. Groq's LPU threatened to carve out the entire, and you could argue more valuable, inference market. So by paying $20 billion, Nvidia eliminated a very dangerous competitor and secured the final piece of the puzzle, creating a complete vertical monopoly over the entire AI stack. So what does all this mean? The pivot is happening. We're entering a brand new era of AI, and the future is specialized. This slide sums it all up beautifully. The future isn't one big AGI. It's a society of DSS, an ecosystem of specialized models. This society is built on a foundation of knowledge graphs and formal logic, which ensures accuracy. And it all runs deterministically on specialized, hyperfast hardware, like the LPU. And maybe the most profound idea here is that this entire paradigm decouples intelligence from massive scale. We're moving away from these energy-devouring centralized data centers and toward a future where secure, expert-level superintelligence can run efficiently right on our devices, at the edge. And this leads us to the final question. As this new breed of AI becomes smaller, faster, and more specialized, it's not a matter of if it will reinvent industries, but which ones will be first. I mean, when you can have a world-class legal, medical, or engineering expert running on your laptop, what does that change? The race is on to answer that question, and the world is about to find out.